have a sort of thing here. What it's going to do is it's going to create a service, a core VM service. So basically a Docker container, if you like. And inside of that Docker container, it's going to put a pre-built version of Doom, right? So let's do that. It's going to build a little bit of code first. Now, when it does this, it should, if it's working, we should see a service pop up here. And it'll initially not know what it is because it won't have uploaded the service code yet. There we go. So that Bootstrap service, that's a sort of, as you might imagine, that's the Bootstrap service, right? That's the service that allows us to load other services. Yeah. So we're loading a core VM service, and there we go. That's just loaded in. Yeah. We've started core VM. That's a core VM process now that's running. And you can see on the graphs there, it used a little bit of core 0 and a little bit of the accumulation processor, yeah, to do that. And now we have 2. It's not doing anything yet, it's just sort of sat there, idle. To make it, it will actually start doing something, but we want to see what's gonna, this process, we want to kind of plug ourselves into its output. And it's got a graphical output, right? And we have a graphical sort of monitor, remote monitor for it, that lets us actually open up or view its graphical output, its video output. Just have to put the thing in there, the service ID, and we'll be able to see it. So this is its graphical output now, as it's running. And there we go. Now, as you see, Core VM is now at the top of the list because it's constantly, churning through compute. Right? It's running on a core of the jam of this computer, this decentralized computer. And you can see it's taking up 5% of the refined core and 3.5% of the accumulation core. And we've actually got it switching between core 0 and core 1. Just to sort of demonstrate, it doesn't necessarily have to sit on one core, right? Every block is going to switch to a different core, and it's still fine. And we can see at the top, we've got our AP, our accumulation processor, that's running at 1.8%, and our cores that are running at, 5.2%. That's how much it takes to execute Doom, right? 5% of a core. So, can execute something, I don't know, about 20 times more complicated than Doom, and it'll still only use one core. Jam has 341 cores. We can see how much gas is being processed. One refine took 80 million gas. That's how much it takes to generate 6 seconds worth of Doom output. And one in the accumulation, it uses 365,000, so a lot less gas. So all it's really doing is checking some hashes and updating some memory items, basically.